the species. And this webinar will gather experts from different value chain to discuss about the solution of the farming on Mars. And today we invite 3 innovators who has the leading in experience in future agriculture and food solution as the captain to lead us to the Mars journey. And our first captain is Dr. Bekia Wormelink from the Wageningen University and Research in the Netherlands. In 2013, Dr. Wormelink started the first large-scale experiment on if the plants could grow on Mars and Moon soil. This research still continues, and today it enlightened a great number. And Dr. Wormelink has the ambitions to build up such a closed, sustainable agricultural ecosystem on Mars and Moon. And we, the current audience, will have the privilege to take the first pick. And Dr. Wormelink, please send your warm greetings to our audience. Dr. Wormelink.
Yes, thank you for the introduction and thank you for inviting me. I'm Wiege Wormelink from Wageningen University and Research. And as already told, I'm trying to grow crops on Mars and the Moon. And I would like to welcome all people who joined. And for me, it's still good morning, but for you, good afternoon. And I will first talk a bit about our experiments in general. Well, the first experiment started in 2013. And the proposal was written a year before. And
Dr. Wormelink, I will first introduce the other 2 panelists, then we will start round 1. Thank you. Now we shift the talk from the first captain, which is really ambitious and curious and impassioned. And I will introduce our second captain, is the Justin Gong, the co-founder of XAG. Justin Gong took the charge of the cooperative strategy, globalization, and marketing in XAG, a brilliant businessman who gate-crashed the Forbes China 30 Under 30 in 2018. And in 2016, Justin founded XAG Academy, which is now educating more than 60,000 young agricultural professionals to embrace the new technology and the sustainable farming concept. Justin will bring his thoughts of the robots, IoT system, AI, and farm management in this webinar. And Justin, please give us the greetings to our attendants, and please use 2 or 3 sentences. Thank you.
Good afternoon, everyone, and good morning, Dr. Wormelink. I'm here at XAG's R&D Center. I think I'm the co-pilot today. Well, Dr. Wormelink is our pilot, and we have another co-pilot, I believe. Thank you.
Thank you so much. Our third captain is an old friend of mine, Isabella, founder and CEO of the ID Capital. Isabella is a really shifter. She has had a 20-year corporate career in the luxury and beverage industry before moving to Singapore in 2012 and setting up Agri Capital, an investment and advisory company with a focus on the food tech and agriculture tech sector. She founded Future Food Asia in 2016, a first of its kind open platform for agtech and food tech innovation in Asia to cope with the challenges of the sustainability. I highly recommend the FFA to anyone who is interested for learning more future technology. And Isabella, please give us your warm welcoming, and please use 2 or 3 sentences to send your greetings. Isabella, please unmute your system. Thank you.
Hello, everybody. Very nice to have you today. Hi, Justin. Hi, Dr. Wormelink. So I have no experience on farming on Mars, but since we have some restrictions in our travel these days, I would like to say to Justin and Dr. Wormelink that next time we will meet on Mars for a coffee.
Oh, great. We hope so. Now I will shortly introduce you the procedure so you will get a clean concept of how this webinar is linked. Our panel discussion will divide it in 3 rounds. And round 1, we will discuss about the general concept of the reason why we explore the martial agriculture solution. And round 2, we will dig on more practical part of the path to make the farming possible of the Mars. And round 3, we will play a little game to serve dishes for tomorrow's table. And dear all attendants, you will have the chance to raise the questions and interact with our guest speakers. Please be prepared. Now I announce the first round begins. A rocket to Mars has launched. And Captain Dr. Vachling, why did you take us human beings so far beyond Earth? And since 2013, you have been leading the Food for Mars and Moon project and to conduct lots of the scientific experiments on growing plants. And where did your idea come from? And what did you want to achieve in the first place through this project? Thank you, Dr. Wormling.
Thank you. Yes, it started all in 2012. I'm an ecologist, and what we do in normal day, when we're not working on Mars, about Mars, not on Mars, is that we look at why do certain plants grow at certain spots and why don't they grow everywhere? Well, and of course the soil is very determining in that. And what we have is a large database with knowledge about where a plant can grow and where not. So which soil pH, which nutrient conditions, which groundwater table, things like that. And here in Wageningen, we always had a small amount of money available for very innovative projects. And I asked several times for money to do more research on this project. And I always got rejected, and they stated, well, it's not innovative enough. So when I was rejected again, I was a bit annoyed, and I was taking a shower, and then I thought, well, now I will come up with something so crazy that, they can't say anymore that it's not innovative. So what I came up with is we have that large database, and we have nowadays a lot of knowledge on the soil that is present on Mars. We know the composition quite well. And I thought I have the big database with a lot of information, and you have information about the soil. I can try to find out which plant species in principle could grow on this soil. Okay, I asked for money again, and a bit to my surprise, I must say, I got the money. And then, and that's something you never do, of course, because first you look into the literature, then you write a proposal, and then you start doing your experiment. But I just wrote it down, and then afterwards, I looked into the literature, and what I found out first, nobody did that before. And secondly, NASA sells soil from Mars. Well, let's say simulants. So not the actual soil, because there's none on Earth, but simulants, close enough to do experiments. And then I changed the total project and started to see if you can grow crops on those Mars and also Moon soil simulants. And we started that in 2013, and already the first experiment was very successful because we were able to grow over 14 different plant species, also wild plant species, so not only crops on these soils. And that was a major task because we had 14 different plant species. We had 20 replicas per species and 3 soils. So we had Moon, Mars simulants, and of course an Earth control to see how it compares to what you could grow on Earth. And we had 5 seeds per pot, and that ends up, when you do the math, to 4,200 seeds. And we were going to follow them every day, we thought, because, well, maybe one germinates, and then you have some results. But much to our surprise, they started germinating immediately. Garden cress, for instance, and also rye, they germinated within 24 hours. And we didn't have one single plant that didn't germinate, although there was a big difference in success. So quite successful, and we got a lot of attention from the press as well. So we were busy with that. Well, almost as busy with the experiment as with the press, but that was nice. Lots of exposure. So we learned several things from that experiment, and one of them is, well, one of the problems we will encounter with these soils is that they are very hydrophobic. So if you add water to it, it stands just still on top and it sips in very slowly. So that's what we already found out. And well, happily, lots of things did grow. And after a few successful experiments afterwards, which we'll be maybe discussing later on, we had already a major crop. We only worked on crop species anymore. So of 10 different crop species, we had so much harvest that not only we could do the scientific analysis, but also we could have an actual meal. So we invited our funders because our projects are totally funded by crowdfunding. I invited them over, and we had the first Martian meal, so made of crops that were grown on the Martian soil simulant. So, and that included, for instance, potatoes, peas, green beans, but also some herbs, because you would like to have some spicy food, not only the crops themselves. So in principle, we know now how to grow the crops on these soils, although there are still things to solve, but we moved on. And we are now looking into what is needed to have a sustainable agricultural ecosystem on Mars. And well, maybe you've seen behind me, I'll lean a bit back. It shows a dome, but we have the picture as well. So Xiwen, can you share it so that everybody can see it?
Okay, so I will ask the help of the Olivia. Please show the graph that we discussed
Olivia?
yesterday.
So we assume, yeah, okay, take that one. Yeah, thank you, Olivia. Olivia is assisting us with the pictures. What we assume is that you see behind that we will live in a dome below ground to protect us from the poisonous radiation, poisonous for us, but also for plants. And we're doing agriculture inside the dome, and that's very handy. We use the soil and the water from Mars, but that also helps us because we will use LED lights. So we have normal radiation with light, so crops will grow optimal, and we use normal Earth atmosphere. So normal Earth pressure, since on Mars, when you're outside, there's almost no air pressure. It's very cold, minus 60 degrees centigrade is normal. And well, we have the radiation. So that are some problems that we think you should do agriculture indoors, but it will help us a lot because most of the circumstances then are the same as on Earth. The only thing we cannot simulate here on Earth is, of course, the lower gravity. But what you see here is where we're working on at the moment. And what we try is to see what is needed as a minimum to grow crops on Mars in a sustainable way. Well, you have here the pea plant and it has to be pollinated. Well, and we will discuss that later on, how we could do that. But our initial proposal was to bring bumblebees and not bees, but maybe we can talk about that later as well. So that is needed, pollination, because, well, bees need to be pollinated. But also what we need below ground are maybe fungi, because they can release phosphate from the actual rock. And nutrients are available in the Martian soil, but it's not that easy for the plants to acquire them, and fungi may help them. What is lacking on Mars is nitrate. That is normal manure for the plant. And that's almost absent, not totally, but almost. And what we came up with is the idea to bring bacteria that can take N2 out of the air. 80% of our air exists of N2 and turn it into nitrate. And they do that in rhizobiums. And we did already some experiments with them. And we know in principle it works with peas. And we want to bring worms, earthworms, to Mars. And that is, you have to recycle all the plant material that isn't eaten by us. Of course, of the pea, you eat the pods or only the seeds, but the rest has to be returned to the soil and has to be broken down and brought into the soil. And worms are very good in doing that. They digest the organic matter and their poo is manure for the plants. And maybe we'll need some bacteria as well to mineralize the organic matter, but that is what we want to bring. And of course, you see them in the middle left, we need humans, astronauts, because they have to eat my crops, and I would like to have their feces, so their pee and their poop is very valuable because that is manure again for my plants. And it's that important. The travel to Mars will, well, maybe take 6 to 9 months. And during that period, of course, people will have to eat as well and have to use the toilet as well. And well, the idea is to store all the feces and also take out, of course, the water out of the urine, but don't get rid of the rest, but keep it and bring it to Mars and then use that as a starter to start agriculture in these soils, to manure the soils. And this is where we're working on. And we did this last winter. We did an experiment with human urine already, and that worked perfectly. Of course, we know it's manure, so it should work, but it worked. And we were very happy with that because that is an important part of our system. And I hope this winter we will do an experiment with human feces. So that's where we're working on at the moment. And yes, thank you. Keep this picture because there's one thing more I would like to talk about now, and that is the radiation. Radiation on Mars is much higher than on Earth because Mars does not have a planetary magnetic field like the Earth has. And that magnetic field blocks dangerous radiation that comes from our sun, but also from the galaxy. So we are protected, but on Mars you are not. And that's a problem for humans, but could also be a problem for plants if you would like to grow them in a normal greenhouse with maybe just a plastic cover or a glass cover, if we are able to build it. But we did some experiments at the University of Delft, where they have their own small nuclear reactor, and they can make cobalt-60, and that radiates the same amount of radiation that you could find on Mars. And we tried that on rye and on garden cress, and you see a picture here of it. And what we see is that cress grows, and rye also grows. But sometimes you see very strange growth and you see necrosis in the leaves, which of course is not good. And this year we looked at propagation. So we had seeds and we from these plants and we replanted them, and we saw that only, well, 30 to 50% of the seeds would germinate. And there you have another indication that radiation actually also affects the plants that you grow on Mars, and that you have to protect them as well. And that's something we're looking into as well. Of course, this is also a big problem for humans, but well, I don't research humans, I only look at plants. So that's it for now. Thank you.
And thank you so much. We learned about that if the person who would like to achieve the innovation should keep trying and also keep determined, learn from the mistakes. And also, Dr. Bormerling enlightened us a lot about the soil stimulation and also how to construct a self-sustained and closed-loop agricultural ecosystem. And thank you so much. So let's turn on the side to the entrepreneur's opinion. So Captain Justin, is the Mars agriculture too far away from us? We've learned that with the year's experiments, also XAG starts to aim eyes to the Mars and has announced to collaborate with the China's Mars stimulation to also co-develop the Marshall autonomous agricultural solutions. Would you also combine a little bit about the Dr. Bormeling's speech and also express your thoughts about the importance and the urgency of exploring the Mars farming? Thank you, Captain Justin.
Thank you, Shiwen, and thank you very much, Captain Vomlink. Yes, as you mentioned, we are facing difficulties on Earth for agriculture. XAG is a company developing unmanned agriculture system for sustainable future. And I believe the reason why we want to start this program is, I actually had this idea years ago when we started developing unmanned system on Earth. Today, the economics on Earth are developing very fast. It's actually too fast that countries are starting fighting with each other. And I think humans need a higher mission. Just like a couple of decades ago, when the US and the Soviet Union had a problem, they aimed at the moon. So a moonshot is always a good idea to solve problems on Earth. That's our first thought. The second thought is today, especially in developing countries like China, we are facing a very fast period of transformation, especially urbanization. In China only, about 12 million people, population moving from the village to cities every year in China. And we are facing labor shortage in the farmland. And we believe in the future, no one will willing to work in the field because it's repeatable, it's tedious, it's a dangerous job. But we still need to eat, right? No matter how advanced our food technology is now, but we still need basic food production from the field, from the polytunnels, greenhouses. So that's the second issue, labor shortage. The third one is agriculture itself on Earth are facing big problems. For example, climate change, for example, disease. And this year we saw a lot of insects developing, become superbugs as well. And also wars and politics. So the uncertainty we are facing on the Earth are threatening our existence. And if you think about the future, the Earth, if these problems keep developing, the Earth will become Mars, which means you're gonna have labor shortage. No one is working in the field and the environment is getting bad. And also people are fighting with each other to fight for the resources. So that's why we had this idea. And since we are developing drones and robots and artificial intelligence on the Earth to help farmers in the village to grow food, we thought, why not we can do something to assimilate the Mars environment. That will inspire more and more young people, developers, to join this program and contribute their yours in the next couple of decades. Probably we can find a solution. And of course, we also think about the Mars, the real Mars, right? I was talking about Earth. And the Mars, it seems to be, it's much more easier than a couple of years ago to reach the Mars. And this year, China launched its exploration equipment to Mars as well. So we believe in a couple of years or maybe 1 decade, we will set foot on Mars. It's possible. But how? Because the Mars is 7 to 9 months away for flight, and it's 2 years away for each close engagement with Earth. So we need to find a solution before we actually set foot on Mars. Otherwise, to transport food to our first colonization is too expensive. That's why we set up this program at XAG. We call this TMG, which means Turn Mars Green program. This program aims to find the super crop that Dr. Vomelink is actually looking at that will be suitable for Martian soil. And the second is to develop Martian agriculture equipment and solutions so that we can grow food automatically on Mars. And then to launch Mars education programs so we can inspire the younger generations that who will be the pilots and the actual astronauts for the Martian exploration programs. Okay, thank you very much.
Thank you, Justin. We really like the idea that you will have make the Mars become the Earth. And let's embrace the Isabella from the capital, ID capital. I have a scientist and entrepreneur who is there enough to set on their feet on the Mars agriculture. As a venture capitalist in the agri-tech sector, how would you to evaluate these innovative projects, and what are the risks and the benefits to brought to us? Thank you, Isabella.
Thank you very much. So first of all, let me stress how exciting it is to see people working on growing food on Mars. I have to say, when you invited me to this conference, I was not very familiar with the space, and I'm still not very much of an expert, but I can bring my perspective as an investor and also somebody who knows quite a bit about innovation. So Justin mentioned it very rightly before. I would call this project a moonshot. And of course, it's a moonshot on Mars, but it's really a moonshot in the sense that it's in a technology context, that's what we call an ambitious, exploratory, groundbreaking project, which is undertaken with a goal, but no expectations of profitability. No clear commercial benefit, or at least I would say the economics of the project have not been worked out at that point of time. So there has been companies adopting this terminology, and first and foremost Google. Then if you think of which are the moonshots, you could hear about Airbnb, Netflix, Uber. But I would say this Mars project is one notch higher. And I like the vision of Dr. Wommeling. I like the vision of Justin. I would like to go back to one of the first sentences where this word was coined. It was President Kennedy, I think in '62. He said, "We choose to go to the moon in this decade." He didn't elaborate on whether it was possible. He set the goal, and then everything has followed behind. So I really, really value the vision of these two gentlemen, captains, to make it happen eventually. For this to happen, you have to accept the idea that you're trying to bring a 10-time improvement, not a plus 10% improvement. You're really trying to change things completely. So there are examples in space exploration, not so much in a commercial manner in agriculture, but what I would like to say is you don't do business in the space without the support of some governments. China is one, the US is another. The obvious third is Japan, which is very, very invested in it. And the fourth one, I would say, is the European Space Agency. Just to give you a couple of metrics, whatever super gigantic VC fund you can think of, typically the assets they would manage are in the region of 1 billion. 1 billion is big, but it's nothing when you want to grow on Mars. Give you a point of reference of a not so big, not so tiny country in terms of R&D spent. The German government is spending about 100 billion euros per year on R&D. So on the one side, you have a gigantic VC fund managing 1 billion. On the other side, the R&D budget of a country, which is 100 billion. Clearly, this project will require the funding of the government, but not only. It's definitely one building block of this. And you know, there are very, very few people like Elon Musk. Elon Musk is a complete exception. But if you go back to the origin of SpaceX, for about a decade, SpaceX has operated off 1 billion cost, which was partly funded by NASA and the government. So it doesn't happen by chance. And even if private capital has a space and has a role to play, I believe private capital in this instance will follow public capital. Few figures, there are about 375 companies in the private space industry. They have received about 19 billion US dollars since 2010. So there is interest, there is money, and there are definitely innovation in that space. In a second stage, I would be very happy to discuss on how to build a case to attract private funding. Private funding has been called upon by crowdfunding platforms, and quite successfully so, but there needs to be some basics of a business model behind, and that's something we can elaborate in a second stage if you have interest in it.
Thank you, Isabella. And this really drive me back from the dream into the reality, and also hear a lot of the interesting facts. Diverse group always make the same more dynamic. So in the round two, we will dig more on the practical part of the pathway to make the farming more possible on Mars. And in this round, I will kindly ask the panelists are free to raise any questions above your among peers and add more inputs at the end of each panelist speech. And Dr. Vomelik, I heard that they are the current attendants, would like to ask the questions how that you could manage such innovative project more financially sustainable, and how did you see this project could go forward? And thank you, Dr. Vomelik.
Yes, thank you. Good question. Because it's difficult. I don't have funding from my government or from NASA or from ESA, unfortunately, because they're not really interested yet in food production. So I'm struggling. And well, as Isabella already said, I do it via crowdfunding, and that works, but it's only a small amount of money. I get about 10,000 euros a year. So that's not much. And I can rent my greenhouse from it and the materials I need, but I cannot be paid from it. So I work 4 days a week, and the 5th day is for Mars. That's how we do it. So it's complicated. As Isabella already said, we are struggling. And crowdfunding is a lot of fun. I like it very much because I get contact with people from all over the world, which is very nice, and they're very enthusiastic. And well, it works to a certain extent, but I made an overall proposal and looked at how much we need to do all the research I would like to do. And then you end up with something like 5 million or 10 million euros for the whole project. And it's still very cheap because one satellite is much more expensive, but it's difficult to get these kind of money. And the 5 million is for the research, and the other 5 million is, and that's a kind of dream of me, that we could build a Mars dome on the campus in Wageningen and do all the research in there, including that we could have people living in there. But it's difficult, yes.
Yeah, since it's so difficult, all the attendants, please also check the chat and you will find the co-funding link of Dr. Vamelink
Thank you.
co-funding program. And also that you summary that you have the project insights about how to build up a sustained agriculture ecosystem on Mars. And if we were able to live on Mars, human beings would have to be farewell to some crop species. And in your opinion, what could be hardest crop that we could grow on Mars?
Yes, well, actually, all the crops we tried up till now, and that's above 20 species now, so 20 different crops, all worked. And I am very surprised by that. The only thing we were struggling with was spinach, and that was not because of the soil, but because of the greenhouse conditions. We did something wrong. Spinach is a long day plant, so when you have short days, it starts to flower. And in the greenhouse, we have optimal conditions for all the plant species, and they like well, 12 to 16 hours light, but spinach grows only, yeah, then it starts to flower immediately and you don't have anything to eat. So it was not because of the soil, but because of a stupid mistake we made, that we were not able to grow spinach. But with what grows very well are potatoes. And I'm very fond of potatoes. I like to eat them. I like my French fries. But there is also a reason to do so. Not only because they were in the movie The Martian, but they were correct because if you look at nutritional value, then the potato is very good. It's excellent. And what helps is, even in our greenhouse, under, well, not the most optimal circumstances, I think, we could grow them in 10 weeks. And that's very quick. And potatoes don't need that much space to grow. And that is very important because, well, everything you have to build on Mars is difficult. It costs energy. That's a problem. It costs materials, difficult. Maybe you need robots to build your greenhouse beforehand or send it over. But everything is not as easy as on Mars. And the less space you need to grow your crops, the better it is. And then the potato is very good. And besides energy, if you don't peel them, you have to wash them though very, very carefully because you don't want to eat the soil. We'll get to that later, I think. Then there are also vitamins in it, but vitamins are also vital. And you have to think of not only peas, tomatoes, green beans, carrots, radish, which we all were able to grow, but you need certain vitamins, especially vitamin E and C, because they can help you to protect you against the damage that Martian radiation may do on your health. Vitamin E and C work in your body in such a way that they can counteract the effect of radiation. And in that way, we can also keep astronauts healthy when you are living over there. So you have to think of that as well. And one thing more I would like to try, and I didn't do it yet, is to grow bamboo. Not for eating, but because it is excellent building material and it's organic building material. And you will be on Mars in a very normally sterile environment with metal and maybe bricks made of Martian soil. And I think to have something organic, a table or a chair made of bamboo, could really help to feel you more at home. So, and we didn't try that yet, but I think bamboo would grow very well because I know it grows in my garden. Even in the Netherlands, it grows in my garden and it grows very fast and very good. So I have high hopes, but we didn't try that yet. We're still focusing on food production.
And thank you so much. Really such a promising land with a lot of the species can grow and almost a picture that Panda was working on. And Captain Justin, I leave the question to you that in so many species that Dr. Vomelin could grow on Mars, which kind of the agriculture technology do you think could be applied on the greenhouse or the systematic approach for the Mars agriculture solution? Thank you, Captain.
Okay, very interesting. So Dr. Vomelink mentioned what to grow and how to grow. So we need to think about if you want to turn Mars into a farm, you need a lot of equipment, actually, and a lot of intelligence. First of all, it's the control. Mars is too far away, so that means we need to communicate. If we need to communicate, that will spend about 21 minutes for the radio to travel. So we cannot use radio control robots, of course. We have to have fully autonomous AI-based robots to do whatever we want to do or whatever they want to do on Mars. And when you think about to build a farm, first you need to build a greenhouse because as Vomelink said, there's no magnetic field on Mars, which means you are exposed to space radiation. And those radiation will crush any kind of DNA and cells so that you cannot regenerate itself, and even have cancer for the animal and people and plants even. So first of all, we need building robots to build our greenhouse. And usually you can dig into the soil, so you can build semi-underground kind of polytunnel to grow our food. And second is we need to prepare a lot of production materials. For example, the soil. The soil itself contains a lot of heavy metal and toxic materials. So we need to prepare the soil using a special kind of a robot to eat it and then to process it. And then fertilizers. Of course, you need nitrogen. You need all kinds of large amount, medium amount, small amount fertilizers for your plants to grow healthy. And the water, of course. Fortunately, we have found some water on Mars. It's ice, actually, on the ground. So we need to find those ice, or we can use, robots to carry them back to the greenhouse, and then we melt them, and then we make water. And once you have water melting in greenhouse, you also have the moisture, and you have some greenhouse gas inside your greenhouse, and you can make sure that the temperature can be stabilized easier. Also, you need to control the sunlight. On Mars, we have sandstorm, and usually it will last a couple of months sometimes. And you need to clean the solar panel, you need to clean the polytunnel so the sunlight can go through and you can grow your plants. And then you will facing another stage of agriculture, which is the farm management. Farm management, including plant protection, including pollination, and also fertilization. Plant protection is easy because you don't have much weed on Mars. You don't have insects at the beginning. You don't have disease if we control well. So the thing you need to think about is pollination. As Vamling said, we can use bumblebee, maybe, but I'm not sure if they can fly well on that gravity situation. And also the air pressure is very low. To keep the same air pressure on Earth, you need to pump a lot of air, and it's dangerous too. So we need to find a way to do artificial pollination. We have tried on Earth using XAG drones in Australia and China to pollinate the fruit trees, and it shows very, very good results. About 17% yield increase at the end of the season. We can use similar way, which means we can dilute and use a special solvent to dilute those pollen collected, and then we can spray on evenly on top of those flowers during the flower season, and that problem can be solved. Fertilization, we can use water-based plantation or soil-based, doesn't matter, because we can use foliar spray for the fertilization. And then now we have the control, we have the preparation of the material, and then we have farm management system. We also need a fail-safe mechanism, right? Because it's not a joke. If you fail one farm, you have nothing to eat at the end of the season. So you have to build a fail-safe mechanism as well. And all those equipment, all those robots are moving around by themselves, which means they are controlled by artificial intelligence. And then you need a very, very strong AI to collect those data, to analysis, make better decision, and also self-evolving as well. So I think that's what I can think of in terms of hardware and software. Thank you.
Yeah, thank you so much. That's Justin also described the practice, what we could grow and how we could apply this technology on the real practice. And Isabella, I would like to ask you the question that since you already seen that the practice in the greenhouse that we are picturing, what do you see the diverse group as such as the scientists and also the entrepreneurs, governments that you mentioned about, also investors like yourself could be integrated as a value chain to also empower the mass solution to make it more reliable? Thank you, Isabella.
Thank you very much. That's very interesting. And the first idea that came to my mind listening to Dr. Wommeling and Justin Gong is that It's a beautiful example of where many discipline needs to converge to come up with a solution, because the solution needs to be very innovative. So we touched upon the topic of funding before, and funding is very important. You like it or not, without funding, these projects would remain ideas. So let me delve into it. I thought of ways to carve out projects that will be benefiting the Earth agriculture. So at the moment, we are trying to feed the population and the growing population with what we have on Earth, and we know the resources are limited, but still, there are many, many things to do. And XAG is a very good case in point. So we cannot just say there is no solution at all on Earth. If you can find ways to leverage the extreme and atypical conditions on Mars to generate new insights, new solutions, new innovations that could be applicable to Earth, that's something that could be a game changer. And Dr. Womeling, you touch upon many things which are music to my ears. You, for instance, you spotted the extreme conditions like the soil being very hydrophobic. You spoke about the bees and the fungi. And again, there are many questions in greenhouses farming on how you pollinate your tomatoes and your strawberries. So likewise, if you take Mars as an example of extreme conditions that push the boundaries of what you need to invent to make farming possible, maybe you can bring some very interesting innovations on Earth. You also spoke about the bioavailability of nutrients. Very interesting. You spoke about fungi, which is a new field of research that many startups are working on at the moment. And last but not least, Mars and many asteroids are also destinations that many companies are starting to investigate for mining. They are trying to find the interesting materials there. So maybe there could be not just technical and scientific innovation, but business model innovations where part of the outcome and part of the deliverable is applicable on Earth, which is where we are living for the longer time. And somehow it's important to keep this into account. By the way, I really love the idea of the bamboo housing, and I would like to see giant pandas there.
Yes, me too. I liked it. And if I may just react to Isabella,
Please do so.
Yes, because what we already did was an experiment with Sahara desert sand, because, well, that's quite similar to what you would find on Mars. It's very salty, so that's a problem. And it's very dry and it has no organic matter anymore. And it's hydrophobic, so those conditions are almost the same. And we did already an experiment to see if we could fertilize these soils again and grow crops on them, which happened in the past, in the 2,000-3,000 years ago. And we even combined that with an experiment on Martian soil. And we know that the Martian soil is also very salty, and we tried some salt-loving plants, Salicornia, to grow on them. You can eat them. They take up the salt, and so they take up the salt from the soil, so you get rid of it, and that worked. So in that way, exactly what you say, Isabella, is that we try to combine it with an experiment that helps also on Earth.
Very interesting. Very, very interesting. And the intake of body nutrient might be different depending on the conditions, and you will definitely learn a lot from it.
Yes.
Justin, please.
Yes, actually, we are also doing some experiment on Earth. In China, we are trying to grow the rice on the desert because it's very important. Actually, study case we are actually doing now is to use seawater, desert, and combine with hybrid rice. How we can grow that on extreme condition, and it worked actually. The yield is not good. It's about 25% to 30% compared with normal rice field, but it's still very good. And when you eat the rice, you can feel some. It's quite salty actually. So we
Yeah,
don't need
thank you, Justin.
when you make fried rice, you don't need to put salt.
Yeah. And here I announce that the round 2 is closed. Now here we will come to play a game to serve dishes on Mars to all the president's attendants here. And let's imagine that we as the Mars farmers to think about the crop that we would like to grow and use your imagination to serve it to the audience. And meantime, I am kindly to ask the attendants to use this period of time to come up some questions that you would like to interact with the panelists. And we will select a few after our little game that provides dishes for you. And Dr. Wormeling, what could we expect from the Dutch?
Well, first of all, to boldly grow where no plant has grown before. To paraphrase Star Trek, famous sentence from that series. But yeah, we will continue one way or another. And the next thing is to work with human feces. And that's also very innovative and new. Because officially we are not allowed to use human feces to grow crops that you will eat on. So that will also for Earth be very innovative.
Yeah, thank you so much. And Captain Justin, what would you like to bring back to our attendance today?
Okay, I think we will, Dr. Varmelink will grow all the plants on Mars. I will bring some coffee because coffee is one of the most hardest plants to grow on Earth. It requires extreme care. And also, I think we not just need to grow food for energy, but also to grow some food to energize the first Martian, explorers. And also, we can bring some Martian coffee back on Earth to sell to regenerate some money to fund our project on Mars.
Will be very expensive coffee.
Yeah.
Of course.
And that is provided diet. And Isabella, what would you like to offer to our curious attendants today?
So with your delicious coffee, Justin, I would bring some delicious cookies made out of worms grown on Mars. And I hope you will enjoy, but I'm sure Dr. Wormeling will enjoy because it's very, very good for the soil.
Yeah, and it's very healthy.
Thank you so much. That we gather a question from the present attendees, and this is a question for the Wormeling. That you said that the most likely scenario on Mars would be the people living indoor and grow food under the greenhouse environment. But is this still possible that we might work out that the solution to grow crops in the Mars in the open field? Thank you, Dr. Wormeling.
Yes, I already discussed that earlier with Justin. And to my opinion, that will be impossible to grow crops outside on Mars. I already explained it's very cold. Temperatures during the night can go below 100 degrees centigrade. So yeah, it's impossible to grow crops under those conditions. When you are lucky, then it goes to 20 degrees centigrade. It's just about the same temperature we have now outside here in Wageningen, but that's very rare. There is no liquid water on Mars. We've never seen it up till now. There is almost no air. The air pressure on Mars is comparable when you go 30,000 meters above Earth. And nothing can grow in that, as far as we know. So, and then there is the radiation. And I know Elon Musk thinks you could make an atmosphere by detonating an atomic bomb on the North Pole. I then think, how stupid is that? But, well, it might work. But the problem is Mars doesn't have a magnetic field. So Mars lost its atmosphere, which it had in the past, because the magnetic field disappeared. So this will happen again. Molecules will ionize and then they will basically float into space. So you will lose your atmosphere. So I don't think that's a sustainable way to go on Mars. And it's something beyond what we can do at the moment. So I don't think it's possible. Sorry. I would love to, but no.
Thank you. I think our audience is trying to push us further to think about the solution on this harsh environment. And Justin, we also have a question for you. like the genetically modified mushroom crops, do you think the technology will experience an environment to adapt better on Mars when they reach there? If not, what directions do we expect?
Okay. Yes, of course, we can try to genetically modify crops to adapt the Martian soil, Martian climate. But I think at the very beginning, we don't know much about the new species, and we don't know how they will perform and evolve on Mars. I think first of all, we need to make a similar condition on Mars than Earth. Luckily, we have very similar gravity, even it's only 20%, less than 20% gravity on Mars, but we already tried in the space station that the plants on Earth can grow. And the second thing is, like any technology, the technology itself will evolve according to the environment. And luckily, we don't have a Greenpeace organization on Mars. So the experiments can be conducted, I believe, at the very beginning to use genetic modified crops to grow in the labs on Mars. In fact, the Mars itself is a lab. So we can try all kinds of directions, and until we find one way to either it's a nature way or it's a artificial way to find the breed. We can try that. And I think Mars. The reason why we choose Mars is because Mars is very similar to Earth. And in the solar system, it's the most close Earth environment. So we can.
A short addition from me. I was once a plant breeder, so my topic as well. We get a student now that will start an experiment to see if he can build in the genes that bacteria are using to break down perchlorate that is present on Mars to get it into the crops, so the crops can directly grow in the soil before you clean it. So we're starting to look into that.
Yeah, thank you so much. And here, Dr. Wormeling, that we also have a question for you and also for the Justin. We noticed that many countries. Can the host help me to mute the attendance, please? Thank you. That I have a question for both of you. That we noticed that many countries have made the efforts, such as the ID capital Isabella mentioned, as Germany. In your opinion, apart from the growing food, what other factors could be met for human survival on Mars? I will start with the Wormeling, please.
Okay, well, it's not really my expertise, and I think Justin will have a lot to say about that. But there are some basic things, of course, you will need besides crops. That is oxygen. Well, crops will produce oxygen, of course, but I would like to have a backup for that, so that you can do it mechanically as well. And obviously, you need housing, you need to go outdoors, you need to travel. And NASA is working on it. I think that's great that they try their first drone. And Justin knows lots about drones on Mars, and that will be very helpful because, first you may live on the surface, maybe below ground, but you could also live in caves, and finding caves could be done by drones. So, and then I'll leave it to Justin because I think he can talk a lot more about this.
Okay, then let's give the floor to the Justin.
Okay, sorry, I didn't get the question clearly. Can you say it again? It's about
what do you expect more other from the growing foods on the Mars, and what do we need on the human survival? Could we use our imagination to also collaborate that?
Okay. Actually, we as human, we have explored Mars for a couple of decades, so we know quite well about Mars, about the planet. about the surface, about the underground conditions, and even all the elements on Mars. So there are some problems we are facing. One is the air pressure is very low on Mars surface because there's very little atmosphere. And the temperature difference is quite huge. So to make people live on Mars, first you need pressurize the suits, pressurize the cabins, housing, and also you need a good clothes to wear to protect you from the temperature drop, also temperature rise, but also radiations, as we mentioned earlier. So the first thing is how to survive on Mars, and then how to make sure you can do things on Mars. And Martian surface, there's no oxygen, so which means all the combustion engine on the Earth cannot work on Mars. That's why Elon Musk is developing, EV, electronic vehicle first, and also you can utilize solar power. We can also bring some nuclear power stations, power cells to Mars to generate power for us during the sandstorm period. So the power is also solved. And then you need to first you need to do some mining. You need to find materials to build. Unless we can grow enough bamboo, to build whatever we want. And then I think the first generation to live on Mars need to find out what to do. Not only just for scientific research, but really meaningful things. And that's the hardest, I think. So the technology itself can help us to survive, no doubt. But
yeah, no doubt. We need more specific.
We as a meaningful animal, we need to find a meaning for the colonization, not just to find some space, but to need to really be able to habit on Mars and become the first generation Martian.
Thank you so much. And that is very philosophy part. And Dr. Wormelink, I have attended called Lucia to ask you a very technical questions. So are you considering to do trials on hydroponic or aeroponic growth system with the Martian soil to have the recycling system with the low water use? Please.
Yes, thank you. Yes, we are only focusing on the soil. But of course, you have hydroponics and aeroponics that are also very useful options. And I would like to add another one, also done in Wageningen, is to grow algae, because they can help. And from algae, well, you can make all kinds of food. They're very healthy, but you can also use them as fuel. So that's even an extra one. But we are not doing, as our small group, doing anything about aeroponics or hydroponics. But what I think is, and in Wageningen, we're working on hydroponics. That's another group. And we know a lot about how to do that. We even have a closed cabin that has been last winter or the winter before to the South Pole. So that was their summer. To try already. It's a very closed system with hydroponics. And it's the size that you could use it also in a spaceship. So that's where we're working on also in Wageningen. And the way I see it is that on Mars, you will have several systems to recycle indeed, but also growing, for instance, potatoes in hydroponics is very difficult, maybe even impossible on a large scale. And so you cannot grow every crop yet in hydroponics. And I would like to have backup systems. NASA also does that always, that you have backup systems. So let's say the hydroponic fails, then you still have the aeroponics and the crops grown in soil, so that you don't, get hungry on Mars like Mark Watney did in the movie. So there are several reasons to work on all 3, 4 different systems. And we're doing one.
I believe so. Then we will also check on the website on the Dr. Wormelink on the Wageningen University. And as much as I would like to continue, our trip to Mars has come to the end. And now I will kindly ask the panelists to use 3 or 4 sentences to summary about this panel. What could you take back from these panelists into the future reaction to your further strategies. And I would like to start with the Captain Justin, please.
Okay, thank you very much, T1. And I think today is really inspiring. And even for me, we are spending time on developing technology every day and helping farmers on Earth to grow. But still, this kind of workshop panel is very, very useful. But I'd like to say at the end of this session is no matter how the technology is advanced today, Earth is still our best home and only home. So we have to really think of when we're developing the system for Mars, we need to think about how to protect the Earth. So I'd like to say, you know, everyone think of Earth all the time, eat well and stay safe.
Really appreciate it. And now the floor is yours, Dr. Welkning.
Well, first, Justin, very good. As an ecologist, I work on climate change effects, so I can just subscribe to that. And that's always what I thought of. Mars is not going to be our second home. We only have a first home. That's our own planet, and we have to be careful with it. I see Mars as, at least for the first period, as a place where maybe 50, 100, 200 people will live. It will be very difficult. It will be harsh, and it will be all about science, I think. And what Justin said, find out what we can do there. Can we mine or not? And that will be, I think, for the first 50 years, the major goal. And of course, to find out if once there was life on Mars, or maybe there is still life on Mars. And I think the way we look at ourselves will totally change when we find that even on our next door planet, we will find some kind of life. And that will change our total perspective on who we are and what we are. And I think that it will be very important and have a huge impact. And I saw there were many questions, many of them in Chinese, which I cannot read, sorry. But I'm very willing to answer the questions if I get some help with the translation afterwards, so that every question will be answered.
Thank you so much. Appreciate your efforts. Your email address and also the website will be posted above the link. And all the presidents attendees, I hope that you will take home some messages from the scientists' findings that Dr. Wormelink expect some technical and scientific part about how to explore the Mars solution further. And also Captain Justin told us about how that we should preserve the Earth and also further develop the Mars solution. And Isabella from At the Capital also drew us from the reality to make sure that financial solution must be sustainable to further develop the innovative projects. So for half a century that we as the human being try to break out our limitation and connect us with the universe. And in the end, I would like to thank all our guest speakers to contribute their unique ideas and opinions to help us better understand what could happen beyond the Earth. And it's really inspired. And I would like to express my highest respect to the present attendants, and you make the journey to trip as a whole. And your curiosity and participation make us reflect what we as the value chain could contribute more. And finally, I would like to send special thanks to Olivia and all the amazing team members of XAG to provide such an invite together as together. And all the panelists, I announce the meeting now is adjourned, and farewell all my friends. Your questions will be noticed about the XAG, and thank you so much for your time. Thank you.
Thank you, everyone. Bye-bye.
Thank you. Bye-bye.
Bye. Bye.
Yeah.
And attendants, if you have more questions, please stay out in the chat and XAG will take care of that and leave your contact information. We'll bring back to you. Thank you so much. Off you go to the Mars, Dr. Wolfgang.
Yes, we will. Bye-bye.
Bye. 感谢大家参与这一次网课活动。如果您还有更多的提问的话，可以留下联系方式。我们主办方的话会收集问题，然后后续发送到您的邮箱。感谢大家的参与。